All right. Hello, math students. Today we're doing 611, our last section with our trig unit. And this one is on solving right triangles using our trig relationship. So today I'm going to use the T130X calculator that I have in my classroom to solve these problems. So like if you are one of those students who want to use one of the calculators I have in the back of the room, you can grab one of these. I did the Desmos calculator on the last lesson video, so go back to the 610 lesson video if you want to see how to do it on the Desmos one. All right, so let's get started. So for each problem, they want us to make a drawing, write an equation, and solve, again, units from them. So we're going to do the odds. I'm assigning the odds. There's a lot here, and it's very repetitive. If you want to do the evens for extra practice, go ahead. But we're just going to do the odds today. So Carrie places a 10-foot ladder against a wall. So 10-foot ladder against a wall. So basically what that means is there's a wall, right? And we have a 10-foot ladder. You kind of see where the right triangle is, I'm assuming. Against the wall. If the ladder makes a 65-degree angle with the level ground, so here's my ground. There's the ground. That means this angle is 65 degrees. How far up the wall is the top of the ladder? How far up? So x. So the ground and the wall, you should know, makes a 90 degrees. So there's my right triangle. So if I have x, 10 feet, and 65 degrees, this side is my angle. So the hypotenuse is always across the right angle. Here's the opposite. And you should see that sine of the angle has to equal the opposite, in this case x, over the hypotenuse 10, in this case 10 feet. So to solve for x, we multiply by 10 on both sides, right? So I have 10 feet, I'll put the feet in later, times, because we're trying to find x feet, the sine of 65 degrees is going to be x. So this is where the calculator comes in. So again, I have my calculator. I don't know sine 65 degrees, so I push sine. Oh, sorry, before that, down here, so you look closer, you see a DEG. That stands for degrees. Some of yours might say REG. So basically, and if it doesn't say DEG, you need to change it to DEG. DEG refers to degrees. If you push this DRG button, it sends you to DEG, READ, GRD. These are different types of units. So radians and degrees are the most common types of units. Radians you really won't get into until Math 3 Honors or Math 3 or pre-calc. So we're going to be using degrees. So make sure your calculator is in degrees, hit enter, and again you'll see a DEG down there. If it's not, you'll see a READ. If you see an READ, push the DRG button and go back to degrees. All right, make sure it's in the right setting. So now I want to find the sine, hit the sine button of 65, because it's 65 degrees. I'll give you a number, 0.96, so I'm going to multiply that by 10. So x is about, I'm going to round to the nearest hundredth, and you'll see that on the quiz, 9.06 feet. And that's how far up the wall, top of the wall, how far up the wall. The answer was 9.06 feet. And that's how we're going to solve all of these problems. All right. So let's continue. Again, we're not doing 2. We're going to do the odds. So 3. In Southern California, there was a 6-mile, so we're going to have these miles as our units, section of the Interstate 5 that increases 2,500 feet in elevation. What is the angle of elevation? So basically they're saying that we have a stretch of the freeway that is 6 miles long, right? And it increases, so we go up in 2,500 feet. They want to know the angle of elevation. Remember, elevation means if you look at a horizontal plane, which is a horizontal plane, again, increase up. Horizontal means it's a right angle. We want to know the angle looking up. The angle looking up is right here. So this is what we're trying to find. I'm going to call it theta. Looked at my last video. We use our Greek letters when talking about trying to find angle measurements. So in this case, we're using theta. So we should see kind of a red flag here. We have 1 unit in feet, 1 unit in miles. So we probably want to convert one to the other. I don't remember exactly how many feet are in a mile, so give me 1 second to look that up. All right, so 1 mile equals 5,280 feet. So basically, we're going to convert to one or to the other. It's up to you. I think I'm going to convert my miles to feet. So my 6 miles, so it's 1 mile to 5,280 feet has to equal 6 miles to x feet. 1 times 6 is 6, so 5,280. 5,280 times 6. Sorry, it's glare. 31,680 feet. So instead of 6 miles, I'm going to put 31,680 feet. Now that we have the same units, I could solve the problem. This is the opposite side over the hypotenuse, so that would be sine. So the sine of theta, I'm losing room, I'm put over here. The sine of theta has to equal my opposite, 2,500 divided by my hypotenuse, 31,680. So what that means is the angle theta equals the sine inverse of 2,500 divided by 31,680. And so we go to sine inverse of 2,500 divided by 3,1,680. And we get about, we get down to the nearest, people say thousands, hundreds, I would probably do thousandth here. Sorry, this one should have been thousandth up here, I did that wrong. 4.526 degrees. I mean, you'll see that the answer's actually, I'll stick to hundredth. Sorry, no. Keep going back and forth. Your AP tests and all those will be doing thousandths, so we'll get to use 2,000. So that'll be 4.2526 degrees is theta. The angle of elevation would be about 4.526 degrees. And there's your units. So I know this is a little trickier. I'm solving these triangles, but we need to practice these. So again, we need to draw those triangles and keep going. If you think you got the idea by now, you could pause the video and try the next one on your own. I am going to keep going through it. Pause, rewind, fast forward as much as you need. All right, again, I'm doing the odds. An airplane is descending as it approaches an airport. If the angle of depression of the plane to the ground is 7% and the plane is 2,000 feet above the ground, what is the distance from the plane to the airport? All right, so most tricky part again with most of these is trying to draw your triangle. So we have an airplane descending. So descending means coming down. So here's my plane. Here's my airport. We're coming down to the airport. Okay. We know the angle of depression. So we have a horizontal line here, right, with the horizon. So that's my angle of depression because we're coming down. So there's my theta. Horizontal and vertical makes a 90-degree angle. Theta is just a variable. If I didn't explain that before, just like x, just like y, it's just an unknown. I'm getting you used to different kinds of variables because in geometry you'll see theta, especially when you go to calculus. Those of you going to Math 3 honors will also see theta as angles as well. All right, plane to the ground is 7 degrees. So this angle measurement, theta, sorry to give it to us, I'm not going to use that variable there. I apologize. Even though I talked about it, is 7 degrees. And the plane is 2,000 feet above the ground. What is the distance from the plane to the airport? So there's x. So again, I'm given the hypotenuse and the opposite. So that means the sine of 7 degrees has to equal 2,000 divided by x. So multiply x to both sides to get x out of the denominator. So x sine of 7 degrees equals 2,000. To get x by itself, we divide by sine of 7 degrees because that's just a number. Sine of 7 degrees is a number. We just haven't done our calculator yet because I'd rather write sine of 7 degrees than the whole decimal. So x is going to be whatever 2,000 divided by sine of 7 degrees is. Since sine is a function of a degree, this is units just kind of cancel, so we're going to find with feet. Okay, so I'm going to do my calculator. 2,000 divided by sine of 7 degrees. It's already in degrees, so I just need to put 7, put my parenthesis, enter. And so that's about, so x is about 16411 point, so 16,411 and 0.2 feet. Again, feet, I usually do 2 or the 100th, degrees are to the 1,000th. I'll just keep it simple and just keep it to the 100th. You keep going back and forth because I know how the AP test would do 1,000, but most measurements in real life, you can't go above 2 decimal places after feet. So I'll have to go back and forth debating between what you need for the real world or what you need for your test, but most of you will know how to round to the thousands or hundredths, so it's really the same. So, okay, anyways, there's my little rant there. Again, fast forwarding, wind as much as you need. And let's continue on. So 5, yeah, that's correct. So let's go on to 7. So 7 will be the last word problem, and then from here, I will go into actually just solving triangles without a word problem, but I do need you to know word problems for my honors. That is a mandatory question. For my twos, that'll be your extra credit question, will be a word problem. All right. All right. So a ramp is used for loading equipment from dock to a ship. So we have a dock, we have the ship. Okay, so going up. The ramp is 10 feet long. This ramp is 10 feet. And the ship is 6 feet higher. So my dock is straight. And there's the ship is 6 feet higher than the dock. What is the angle of elevation? So that's just theta. Again, for some reason, they're not giving us the opposite and hypotenuse. So I'm going to use the sine of theta equals 6 over 10. So the inverse sine of 6 over 10, because the opposite of sine is inverse, is theta. So theta is going to equal, again, calculator says sine inverse is in blue. So you hit the second for blue. So second sine. So now you see the sine inverse function of 6 divided by 10. Close your parenthesis. And that gets us to 36.869, so 0.87 degrees. All right. And that's the end of the word problem. So again, you have to, for these specifically, you have to pull out your information, ramp from where to where, and then draw your picture. Don't forget your units, and there you have it. Now, for each rectangle below, find all unknown letter sides and lengths. So this one we all should be able to do. So this will be mandatory quiz. All right, so we shall be able to solve these. So again, I'm going to do the odds. If you want fractions, you're going to do the evens. So number 9, I'm given the hypotenuse and a leg. So to find b, I'm going to use Pythagorean theorem. In this case, I just see that first. I do sides first. For some reason, you do it any way you want to. But in my order, that's just what I'm doing it. So 20 squared has to equal 7 squared plus b squared. Pythagorean theorem, right? 20 times 20, 2 times 2 is 4, 2 zeros, so 400 equals 49 plus b squared. If you don't trust me on that, again, 20 squared, 400, minus 49, so 400 minus 49, 351. So b squared is 351, square root. Do I know that one? I'm not sure, so I'll do second square root of 351. That's not a whole number, so I'll probably leave it as that. B is the square root of 351. Can I simplify that? So can I do 351 divided by 3? 117. 117 divided by 3, 39. So that means 351 divided by 9 is 39. So that means that's the same as square root of 39 times 9. So b equals 3 square root 39. 39, 3, and 13. Those are both prime. So we'll keep b as 3 square root 39. On your quiz, I want all sine lengths, if you can, my Pythagorean theorem, be in this form. I'll show you later. I don't know if I can do later. We'll show you how we might be able to do decimals. So for instance, if I did, I'll show you how I might get the decimal form. All right, sorry. So that's the way of doing Pythagorean theorem. If you do Pythagorean theorem, I'd want the answer in simplified square root form. All right. So if you see the answer in simplified square root form, your answer has to be simplified square root form. So theta and beta, I'm going to use 7 and 20. So theta is going to be the sine. We've been doing sine a lot, so I'm going to do beta. So beta, 7 and 20, is adjacent in hypotenuse. So cosine of beta, beta is the Greek letter for b, another variable, is adjacent over hypotenuse. So that means beta is going to equal the cosine inverse of 7 over 20. So cosine inverse 7 divided by 20, and that is about 69.51 degrees. Now to find theta, I know 90, beta and theta have to equal 90, so theta is going to equal 90 minus 69.51. 90 minus 65, whoops, 90 minus 69.51, so theta is 20.49 degrees. So that's the simple, easiest way, I think, to find beta and theta. However, to find theta, I could have done cosine of 7 and 20. B, I could, now that I have beta and theta, you could find B by doing, so for instance, if I wanted to find B again, I could say that the sine of 69.51 degrees has to equal B over 20. So B is going to equal 20 times the sine of 69.51 degrees. And this one I'll have a decimal answer. So sine of 69.51 times 10. Oh, sorry, I had that wrong. Sine of 69.51 times 20. So then B would be 18.73, right? But if you also do the square root of 39 times 3, you also get 18.37. 18.73. So it's the same answer, but one's in simplified radical form and one's as a decimal. So you get Mr. Honda, well, which one are you going to want for the quiz? Well, since your quiz is multiple choice, you have to look at the answers and know which one to do. If I give you the decimal form, that means I expect you to know how to use the trig function. Or, okay, if I give you the decimal form, that's pretty much easier. You have to do the trig function, or you could just put this in your calculator. If I give you the simplified radical form, I want you to get that by Pythagorean theorem. And I can only expect you to do that by Pythagorean theorem if I give you 2 sine lengths. If I don't give you 2 sine lengths, like question 8 does, then you'll get your decimal. But again, you have to look at the question. So again, I'm doing the odds. If you want me to do 8 in class, let me know. 11, 2020, find the third. So pretty easy here. So 20. This is so this is what we call an isosceles right triangle. Isosceles right triangles we know have the same sine lengths. Same sine lengths means these angles are congruent. Angles are congruent. These are 45-degree triangles. So isosceles triangle. Angles are congruent. So that means theta equals beta. So 2 times theta is 90 degrees. So theta equals beta, which equals 45 degrees. All right, so that's how I found theta and beta, by just doing 90 divided by 2, and both of them are 45 degrees. So to find the hypotenuse, I could either do any of my trig, or I could do Pythagorean theorem. I'm going to do Pythagorean theorem because I want us to practice simplifying square roots. So I'm going to do 20 squared plus 20 squared equals c squared, because this is c, my hypotenuse. 20 is 400 plus 400 equals c squared, so c squared equals 800. Square root, c is the square root of 800. Or c is the square root of 2 times 400, which is 20 square root 2. Interesting. All the hypotenuse is your sine length times the square root of 2. Huh. I wonder if that's true for all isosceles triangles, right triangles. You could go back and check, and it probably is. Sine length times square root of 2. Anyways, little key things here I'm noting that you'll probably have to know as a pattern in a AP Pre-Calc or 3 honors class. Anywho, let's continue. So now 13 and 15. I'm just going to do 14 down here. I'm getting a little tired with these ones. Been doing this for 20 minutes now. Again, you can fast forward, pause, rewind. But I'm just going to do the even one here. Your task is the odds, but I'm going to do the even one. You do the odds on your own. I trust you. Determine the values of the 2 remaining trig ratios of the given 1 trig ratio. Basically, they're saying if tangent of theta is 8/3, they want the sine of theta and the cosine of theta. The reason I want you to do most of these two on your own is because these are exactly the quiz questions I will be asking you. So I want to do one more example for you, but by this point of this packet, you should know how to do this. So I'm going to have my right triangle. I'll have an angle theta that's not the right triangle. Tangent means opposite over adjacent. So opposite has to be 8, adjacent has to be 3. So 8 squared plus 3 squared equals c squared. 64 plus 9 equals c squared. 64 plus 10, 74 minus 1, 73 is c squared. C is the square root of 73. I don't think I could simplify that one. Actually, let's do 73 divided by 9. No. 73 divided by 4. No. Nope. So this is going to be the square root of 73. So that means that my sine of theta is 8 over square root of 73. So multiply by square root of 73 over square root of 73. So that'll be 8 square root of 73 divided by 73. Okay. And my cosine of theta will be 3 over square root of 73. So multiply square root of 73 over square root of 73. If you haven't noticed by now, I'm just multiplying by the denominator. So that's 3 square root 73 over 73. So cosine is 3 square root 73 divided by 73. And there's your 2 remaining trig ratios for that one. I know this was a long lesson video, but this is our last review one before the quiz. If you could do, basically, those 15 questions are basically the quiz questions because they go over everything we learned in trig. They go over what trig ratio you have to use, sine, cosine, tangent, sine, cosine, or tangent. They go over Pythagorean theorem. You apply it in a word problem. You have to find missing angles, missing sine lengths. So if you want to do another practice quiz, do the evens. All right. Thank you for watching this, and yeah, you got it.